Hello, this video is part 1 on law of cosines. In part 2 we will be making a Python program that will do everything we will do here. All the computations done in this video will be done in the second video using Python. So just like law of sines, law of cosines is very useful when we deal with angles of elevation and depression, or when we have a triangle composed within another triangle, such as we saw in the example of law of sines, the application when we looked at the balloon problem. So there are many applications in law of cosines, just like in law of sines, but the difference between the two is that the law of cosines arises under these two conditions. That's when we use law of cosines. We have to use law of cosines, and we cannot use anything else to solve our triangles. The first one is that when we have two angles and two sides and an angle sandwiched right in between these sides. So just like this first example here, we have two known sides and an angle right in between. If say we knew angle A or B, we can use law of sines and solve the whole triangle because we know the sides A and B. But since we don't know angles A and B, and we've been given the sides of those angles, the corresponding sides, the opposite of those angles, then and we are given the angle in between those two sides, then we have to use law of cosines. We don't have any other choice. And then the second condition is when we have three sides. So SSS. We have known three sides. In this case, we know A, B, and C. They're all given to us, and the only way to solve our entire triangle is to use law of cosines. There's no way to solve this using law of sines because we don't know any angles in this problem. We only know sides. All right, and then we have the equation, the formula for law of cosines. Let me erase this stuff here. So we have the formula. This is the big major formula that is doing everything in this section. That it says a squared equal b squared plus c squared minus 2bc cosine of a, the angle. Capital A would be the angle, and lowercase letters are the sides. And in this equation, in the second one I have down here, I have derived it from the first equation. That's why I said the first equation is the most important one. And this equation is useful when we solve for an angle only. So the first one is definitely the most useful for solving any sides, when we solve for sides. And the second one is when we need to find angles, such as in this problem. We will definitely be using the second one at least once. Well, once we find one of the angles, then we will do another idea, a strategy to solve the rest of the angles that we will go over. All right, so let me erase this stuff here, come down here, and we are going to solve for in the first example, we're going to solve the first triangle that we looked at that goes over an angle centers between two sides. So in this case, we know one of the angles, and we're given two sides, and we need to solve a third side and two other angles. So what I'm going to do is I'm going to make this bigger, and then we're going to solve our triangle using law of cosines. So what I'm going to do is I'm going to copy and paste the equation that we have up here, down there. So actually, let me see if it does that. Okay, good. All right, so I copied and pasted the equation. So now I can use this equation because I don't have it memorized. I don't have that equation memorized. So what I'm going to do is now I'm going to solve. Okay, good. All right, so I'm going to solve the triangles using this equation here. So we can start with any. We can start with angle A, angle B, or the side C there. So what I'm going to do is I'm going to solve for sides. Let's actually solve for, yes, side C using this equation, using the equation that I copied and pasted. So to do that, we're gonna say c squared. We can change this equation to solve for sides. We have to account for the changing variables in that case. So in this case, we're gonna have solving for c. So c squared equals b squared plus a squared minus 2ab cosine of capital C. So that's the law of cosines equation, in this case solving for C. And now we can start plugging numbers. So C equals b squared is 24. So 24 squared plus 18 squared minus 2ab So AB in this case is, or BA, AB, doesn't matter. 18 times 24, since we're multiplying, doesn't matter. Cosine of angle C, that's the important information we know, is 57. If we didn't know cosine of C, we couldn't use the law of cosines because we can't solve for two variables in one equation. So then this is C squared. All right, so C equals square root of this all of this. So 24 squared plus 18 squared minus 218 24 cosine of 57. 57. All right. So I can now, this is a calculator problem. Let me go ahead and use my calculator, and I'm going to solve this, see what we get. All right, so using our calculator, 24 squared, this is plus 18 squared, minus 2 times 18 times 24 cosine of 57. I believe that's, so yes, so then we have C equals 20.72. It's approximation, so we're going to use that symbol instead. This is an exact answer up here. This is all an exact answer. But then once we are going to round out, this is going to have this symbol 20.72. Let me just double check if that was what the calculator, yes. All right, so that is side C. So now I can solve for, I'm going to solve for angles A or B. So solve for, let's solve for angle A. Can we use law of cosine, law of sines here, or no? We still, yes, we can use law of sines here now. So if I go back up, we already know C, and we know lowercase c. We just found that, and we know the angle C, 57. So now I can use law of sines. Whenever it's convenient, whenever I can, our first option of solving problems is using law of sines. Then, if not, if we can't use it, then we will use law of cosines, because law of sines is much easier to work with. It's less computations and less likelihood of making errors. So use law of sines here. We're gonna say sine of 57 over 20.72 equals sine A, and we know A, lowercase a, is 18. All right, so then 20.72 times sine of A equals 18 times sine 57. Let me come down here now. So then isolating A, or sine of A for now, so we have sine of A equals 18.5, or so 18 times sine 57 over 20.72. So that means A equals inverse sine of this whole chunk, this chunk here. So 18 sine 57 all over 20.72. So this is now a calculator problem. A is I'm going to get an approximation here, rounded to two decimal places. Let's grab our calculator and type that in there. So we're going to say inverse sine of 18 times sine 57. Close that, and then this is divided by 20.72. So A is approximately 46.77 degrees. 46.77 degrees, using law of sines. All right. So now that I've found A, I can solve for the last angle, in this case, B. So that means measure of angle B equals 180 minus, the other angle is 57, I believe. Yes, angle C is 57. So this is 57 plus 46.77. So this should be an approximation because we did approximate angle A, so therefore we are in territory of approximation already. So measure of angle B then equals, let's grab our calculator again. So 180 minus 57 plus 46.77, and we get 76.23. 76.23. Let's see if that makes sense. Angle B looks very similar to angle A in measurement, but based on our calculation, that's what we got. Let's erase that. So we got, therefore, what did we find? I always like to put last, in our conclusion what we just found out. So we found, first of all, we found length C, and then we found angle A, and then angle B. So length C, lowercase c, equals 20.72. Measure of angle A, we said 46.77, and then measure of angle B is approximately, these should be all approximations here. If we can put the symbol there, we're approximating. And then angle B we said is 76.23. All right, so that's how we do that first problem.